And now, ladies and gentlemen, I give to you the last lesson. Using geometric formulas to find the probability of an event. This is a word that represents what we're looking for. Here we go. A rectangular garden is 10 by 15 feet. I'm going to draw a quick picture. 10 feet by 15 feet. The tomatoes are planted in a rectangular area that is 3 by 12. So draw that 3 by 12. A ball lands in the garden. Find the probability that it landed in the tomatoes. So what we're going to do is find the area of the tomatoes, which is 36 square feet. But the entire garden is 150 square feet. So the probability of the ball landing in the tomatoes is 36 out of 150. Of course, take your answer there and reduce it, and you'll have your final probability of the ball landing inside the tomato portion of the garden. Here's our final answer. If 25 balls were thrown into the garden, 6 of them would land inside the tomato portion. Try this guy on your own. We want to find the probability of the dart landing inside this right there. So we're going to find the area of the interior circle, which is going to be pi radius squared, over the area of the entire target, which is pi 12 squared. Okay, the area of the interior guy is 16 pi. The area of the entire target is 144 pi. And you'll see here that the pi's are going to cancel away. So choppy choppy, and then take this and reduce it using your calculator. Here's a recap if you forgot. Go to the calc, type in 16 divided by 144. Hit the math button over here. And you want the first option, fraction, hit enter, enter one more time, and then it reduces it for you, 1 out of 9. So, if we were to throw 9 darts, only one of them would hit the interior portion. Give this one a try. It's different than before, so read carefully and take your time. Pause the video if you need to. This is how I'm going to draw my picture. We've got a circular town with a diameter of 50 miles or a radius of 25 miles. And then there's a park that has a 5-mile length all the way around, or 5-mile sides. So I want to know the probability of a raindrop landing inside the town but not in the park. So I'm actually going to find the probability of a raindrop landing in the park first. So the area of our park is 25 divided by the area of the entire town, which is pi radius squared, due to the fact that the town is a circle. So calculate that. We're going to have 25 over 625 pi. Now, you see how there's no pi to cancel. Let's go ahead and reduce the 25 over 625. This gives us 1 over 25 pi. Here's our probability of a raindrop landing inside the park, but this is difficult to understand. So I'm going to have you calculate this using 3.14, and it's going to give us 1 over 78. About. So if 78 raindrops fall, only one of them is going to land inside the park. But the question asks, what is the probability of a raindrop landing in the town but not in the park? So if 78 raindrops fall, 77 of them will land in the town and one of them will land in the park. So this right there is your final answer. Again, we're looking for a dart landing outside of the triangle. So first, find the probability of the dart landing inside the triangle. The area of our triangle is base times height divided by 2, which is going to give us 7 square feet. Then the area of the entire target is 49. So I can reduce that to 1/7. So throwing 7 darts, one of them is going to land inside, but the question says, what's the probability of landing outside? So if one lands in, of the 7 that we throw, 6 of 7 are going to land out here somewhere. There's our answer right there.